you're being taped right now.
Well, that's fine.
Oh. Okay.
Why are you taping me?
So in case people want to review it.
Okay.
Alright, so we're going to look at the law of sines. And just like we kind of looked at where the law of cosines came from, it came from the distance formula. And actually you'll find out that most of the trig stuff that we do can be like worked backwards all the way back to the distance formula. Like it all kind of comes from the same place. The law of sines comes from a slightly different place. So I want to start there. Okay. Let's start with a triangle. We're going to label that triangle ABC. And then I want you to draw in the altitude of that triangle and label it as H. I think we'll also need to label sides. So side A, side B, side C. Okay, for any triangle, getting back to geometry, what's the formula to find the area of any triangle? Like 1/2 base times height, right? Okay. So write that down, that the area equals 1/2 base times height. Now, we have the base, like if we're looking for the area of this whole triangle here, the base would be side B, right? Technically. And then this height here would be given to us. But we need actually everything written in terms of A, B, and C. Or we can write everything in terms of A, B, and C if we play around with that H a little bit, using some of the trick stuff that we've already talked about. Okay, so we're going to use the fact that if I look at this angle A here, that sine of A, would be the opposite, so that'd be H, right? Over what? The hypotenuse. What's the hypotenuse of that right triangle that you see there? C. Okay. Now, I'm going to rewrite H. I'm going to rewrite this formula now that we know is true, because that's a right triangle within this bigger one. I'm going to rewrite this so that H is by itself. How do I rewrite it so H is by itself? So we're going to multiply by C. And so I can say that H, or that altitude, that height, is the same thing as saying, okay, I'm going to take my side C and multiply it by sine of angle A. We've made an equivalent statement here. And so in this formula, I'm going to replace H with C sine A, because I've said H is equal to that expression. Why this area formula is nice is because it takes away the need to know the altitude. All you need is an angle measure and the sides. And you're good. So it's the same formula, it's just we adjusted the height to be an expression instead that we can use. The reason we talk about this is because when you go to use the law of sines, it comes from this formula. Okay? So it takes this formula, the law of sines, because we know this is true to find the area. It takes 1/2, I don't know if I'm going to have room here, 1/2 BC sine A. And it says, okay, if we use the same triangle, I could move my variables around a little bit to write a different expression that will be the same area. So I could say, all right, this is the same thing as saying AC sine of angle B, right? It'd be the same, it'd just be a different right triangle that we were using. And then this would be the same thing as saying 1/2 of AB sine C. So all three of these would get us the same value depending on, like if we had angle B, we'd use the middle one. Yes, Heather?
So we only can use semi triangles, right? Because that's like the...
No, this finds the area of any triangle.
Oh, but you needed to be like a right triangle for your whole...
Yeah, but we have, like you can draw a right triangle within any.
Okay.
Yeah. That's why we're able to adjust it. And then what they did is they said, okay, there's some stuff that's common between most of these expressions. Like, what's one thing that's common in every single one?
1/2.
1/2. So we're going to divide that out. And then I'm going to divide out, like, 2 of my expressions have A, 2 of my expressions have B, the other 2 expressions have C. So I'm going to actually divide everything by A, B, C. And you'll see what happens. In the first expression, like if we just look at those 2, what cancels out?
1/2
1/2.
BC.
The 1/2 and the BC. So we're left with sine A over A. Okay, so sine A over A. If we look at the middle, what cancels out? AC and the 1/2. So we're left with sine B over
C.
B. And in the third expression, AB cancels out and the 1/2 cancels out, leaving you with sine C over C. That is the law of sines. That in any triangle ABC, the ratio of the sine of the angle, whoops, you can't see that, sorry. The ratio of the sine of an angle over the corresponding side is equal to the sine of B over the corresponding side, and that's also equal to the sine of C over the corresponding side. When we use this in an actual problem, you only ever use 2 of the ratios at once. So you don't have like 3 fractions that equal to each other ever. You just pick the 2 that make sense to pair. And let's actually do a problem like this. Well, and I should back up because we didn't go over why we need the law of sines. In the law of cosines, if we're given 2 angles and one side, can we figure out that problem? Oh, shoot, I don't have it written down here. We only have, like, in the law of cosines, the only angle that's ever in the problem is the last cosine of whatever, right? So if you're given 2 angles, it's not helpful because you need at least 2 sides to plug into that law. And so this law allows us to have 2 angles and one side and still be able to find the values for any legs or any angles. All right, so the first example we're going to look at is this triangle. We're going to just use ABC again. So in triangle ABC, angle B is going to be 64 degrees. Angle C is going to be 38 degrees. And side B is going to be 9 feet. And I want you to find the length of A and C. Okay, let's start with drawing our triangle. So B is 64, C is 38. Can I find angle A from that information? Yeah, because all angles in a triangle add up to 180. So let's take 180, subtract 64 and 38, and tell me what's left over. 78? All right. The other piece of information they give me is that side B is 9. To set up the law of sines, you always start with the pairing that they give you. What's the pairing that they give me right now? Pairing meaning like angle and side that go together. Angle B, right? Because angle B has the side length for B. So that's the first ratio I'm going to start with. I know that sine of 64 degrees over the side that's paired with it, so sine of 64 over 9, is going to be equal to one of these other ratios up here. So we want to find side C, we want to find side A, so let's start there. So this is going to be equal to sine of A, which is 78, over side A, which is our unknown. So this is sine of B over side B is going to equal sine of A over side A. Now we got to solve for A. Now, with these, since you have 2 fractions that equal each other, just cross multiply. That's probably the fastest way to do it. So sine of 64 times A gives me that expression equal to 9 times sine of 78. And so A is going to equal 9 times sine of 78 degrees divided by sine of 64. Yes?
So does it matter if the A is in front of the sign or after?
It does. I mean, it does when they are, it does because if you were to punch that out and you had sine of 78 and maybe you wrote it sloppily or something, the 9 was over there, you'd want to punch out 789 with it. And that same thing with variables, you always want variables with whole numbers in front of the sign function. Now, I think it's going to be important here that you put the top, the numerator, in parentheses. You should get, let me make sure that that's right, because I'm not sure now. Is that what you got?
Yeah.
Yep, okay. So 9.795. And we're in feet. Now we have to find side C. And I actually start with the same kind of setup. I use the pairing that they give me right off the bat. That sine of 64 is paired with side valued 9. And then what would I write over here? Anybody? Sine of 38 over C. Good. Cross multiply. Anyone can punch that out? Anybody there yet? What do you get?
6.164.
Good. That's what you should have gotten. Yes, sir.
So this is the same as putting the side over the angle. Because last year in Goobs we did that. It did the same thing, right? Because I just did that and I got the same thing.
The side over the angle.
Side
You
over
just
the
had them flip-flopped? I think that would be fine. Because after you cross multiply, it would end up being the same thing. Yep. Okay, let's go to example 2. We'll do this one together, and then I'll probably let you do the last one on your own. See how you do? Okay.
Triangle jaw.
I'll make you find one side this time. Has anybody found my angle A yet? Thanks, Carol. Angle A? What? 59? I'm looking for angle A, because we can add these up and take it away from 180. I heard 59, but with a question mark. Okay, 59, good. Alright, so let's go with Nick. What would be the first pairing that you put up there? Like, where would you start? What fraction?
Yeah, A.
A? Why would you pick A?
Because someone else said.
Where's the pairings that I'm talking about?
Because you have side A.
Good, because you have side A. So you're given angle A, or you had to find angle A, but you were given side A, so that's the first pairing that we start with. So sine of 59 is going to go over side 5. And then we want to find J.
Sine of 48 over J.
Good, so we should have the sine of 48, because that's what angle J is. Over j. That's what we're looking for. Then you cross multiply. Okay. And then go ahead and punch that out.
$4.33.
4.33. And I didn't give you any units, so I'm just going to say units for units. There you go. I was going to have you do example 3 on your own, but I'm actually not going to because I'm changing something up on you. So I want to make sure that we walk through this one together. Okay, let's go with
I just did quick.
okay. We have a slightly different situation here. Can someone tell me what's different about the information I just gave you?
Sides.
I have 3 sides. What's the other piece of information that I've been giving you, but I'm not giving you this time?
Find an angle.
We have to find an angle, because all the other problems we've done, I've given you 2 angles. Now we have to find one. So you set up or label your triangle. It's good to have a picture to work from. So 2, 3, 4. Angle A. And I want to find angle B. Okay. You're going to still start with your pairing. Michaela, what is my pairing for this one? A. Good. So I'm going to start with sine of 28.96 over 2. And I want to find angle B. So it'll be sine of B over what? Over 3. Good, because that's side B. We still set it up kind of the same way. So we're going to cross multiply still. And you get 3 sine of 28.96 equals 2 sine of B. And so sine of B is going to equal 3 sine 28.96 divided by 2. Excuse me. What do you get when you punch that out?
0.726.
0.726? Is that what you said?
Oh yeah, yeah.
0.726?
Yeah.
Okay. Now,
Inversing.
not yet.
Oh.
I haven't yet. Alright, so at this point, if I want to find angle B is right now stuck in the argument of sine. How do I get rid of the function sine? Careful of the way you say it.
Inverse.
The inverse sine. Good. Inverse function for sine. Those will cancel, because opposite functions cancel, leaving me with B. And then we have to actually punch out inverse sine of 0.726. 46 point, I have 577.
I have 46.55.
55? 2? I'll go that. I guess it depends on if you use the answer key or if you use 0.726. Okay? So same setup, it's just you have to do a little bit more work on the end there because you have to actually solve for an angle. Okay. You ready to do some stuff on your own?
Yeah.
Okay.